This is Bill Levinson with Levinson Productivity Systems. Thank you for listening. We're talking about principles of green and sustainable manufacturing. Part 4 covered something called the control surface and material and energy balance for identifying material and energy waste in the manufacturing process. Now we're going to look at some actual examples of green manufacturing. Some brief case studies of green manufacturing. Henry Ford actually developed zero-emission manufacturing. He said the ideal is to have nothing to salvage, nothing is emitted or thrown away until no further value can be extracted from it. Henry Ford, as a matter of fact, got coal for effectively less than nothing, or actually coke for his blast furnace for less than nothing. The coal cost $5 a ton. Coking of the coal, as opposed to burning it directly for power, yielded coke, which is basically carbon used in the blast furnace to reduce the iron ore to iron. Also, coal chemicals, and those together were worth $12 a ton. The chemicals included sulfur and other would-be pollutants, even though at the time there was no law whatsoever against emitting sulfur oxides, which are now recognized as a component of acid rain. Ford wrote emphatically that burning coal as coal was enormous waste because you were also burning the coal chemicals, which were worth far more as chemicals than they were as fuel. Here's zero-emission coal in pictures. Just burning the coal gives you sulfur and nitrogen oxides. Now those are recognized as hazards to human life, also a component of acid rain, so you have to pay to scrub those out of your stack gases if you emit them. Well, what Ford did, he had a coking process. He got coal chemicals. The sulfur was recovered as ammonium sulfate, which could be sold as fertilizer. So instead of becoming a pollutant that today you would have to pay to scrub out of your stack gases, Ford made something you could sell. That sounds like win-win all around. And what you ended up with was straight carbon dioxide as a combustion product, perfectly clean. As we stated earlier, Levinson Productivity Systems does not support things like carbon taxes or cap and trade or any of that stuff. We don't recognize that as a legitimate agenda. The goal of green manufacturing, as we see it, is to eliminate waste and not carbon dioxide for its own sake. However, and there is always a however, a perfect green manufacturing process's remaining carbon emissions are non-negotiable with the basic laws of nature. So if you are worried about carbon emissions, everything you're learning to do from this video is consistent with reducing those emissions, because you're eliminating energy waste. If your energy comes from carbon sources, you're going to reduce your consumption of fossil fuels. If, on the other hand, if your energy is from hydroelectric or nuclear, you're going to save money, and the carbon footprint is not going to identify any waste of nuclear or hydropower for you. Paint parts, not air. This is from Shigeo Shingo, a Japanese quality and productivity experts. He cited the case where paint that missed pen caps became an environmental problem. Actually, it was getting into the water, and rice farmers were complaining about this stuff getting into their water. So you had two problems. You had a pollutant, and you were also throwing away the paint. And Shigeo Shingo said is the objective to paint the parts or the air, and if you're in the spray booth, you're painting primarily the air. They redesigned the system to rotate the caps in front of miniature sprayers. It used almost all the paint, so they had to pay for less paint. It also eliminated their environmental problem, so that was a win-win solution. Something as simple as changing the font of what you print can reduce your printer ink consumption. Certainly, if the ink cartridges are an environmental problem, compared to other things, they aren't, because they're relatively small, but they certainly cost money. And if you reduce your ink requirements 30%, you reduce your office supply at least as far as printer ink goes, by 30%. No problem there. Bypass thermodynamic efficiency limits. We've seen processes that mix coal with very hot steam to make hydrogen and carbon dioxide. The advantage is that hydrogen is usable in fuel cells which are not subject to the Carnot cycle's efficiency limit. The Carnot cycle is the ratio of the temperature difference between the hot reservoir or furnace and cold reservoir divided by the temperature of the hot reservoir, and that's all measured in degrees Kelvin or Rankine, and actually that's a theoretical cycle. The real cycles, like the Rankine cycle for steam, are actually less efficient than the Carnot cycle, but if you have a fuel cell, you can bypass the thermodynamic efficiency limit of the Carnot cycle. There are enormous wastes in agriculture. Material waste can be far worse. If you look at a control surface for a farm, you can see an enormous amount of waste. Take a look at this. You put in fertilizer and water. How much goes to the crops? How much goes to runoff or groundwater? Actually, quite a bit can get into groundwater. The fertilizer can even become an environmental problem. The farmer not only has to pay for the fertilizer, but then has to worry about it getting into the groundwater. This is why the control surface approach is so useful. Question how much fertilizer is used by crops, how much is runoff. If you purchase water for irrigation, how much is used by crops, how much is lost to the ground or evaporation. Well, the traditional farm is probably, well, how old is agriculture and human civilization? Maybe 4,000, 5,000 years old when it began to grow up around the Nile River and the other cradles of civilization. Farming, putting seeds in the ground, adding water, and growing things is thousands of years old. By this time there ought to be a better way to do it. Hydroponic farming, vertical farms, greenhouses, they would have higher capital costs than the farm, but those capital costs are offset by no waste of water or fertilizer. Everything you buy is used by your crops. If completely enclosed, you don't need pesticides. You need less land area if you have a vertical farm. You don't have tractors, extremely expensive pieces of equipment, or their fuel costs. Also, you have year-round production capability. A company called Sweetwater Organics is doing something called aquaponics, where they raise, it's a hydroponic fish farm, uses urban waste streams to produce rich soil. The soil nourishes plants. The plants nourish the fish and use the fish waste, produces fish and other products. Seems to be a completely enclosed system that uses absolutely everything, which is, again, green, sustainable, and probably highly profitable. Aquaponics, you have a primarily closed ecosystem. It's similar to a chemical process, and chemical engineers try to make sure everything is recycled, reused, till it can't be used anymore. Wastes absolutely nothing, and it even consumes municipal waste. Okay, summary of the entire presentation. Green manufacturing and ISO 14001, and now we have ISO 50001, are enormously profitable if used properly. This was proved by Henry Ford. It's consistent with and part of lean manufacturing. We defined a perfect green manufacturing process as one from which material and energy wastes are absent. The remaining material and energy usage are non-negotiable with the laws of nature. That's how you identify a perfect green manufacturing process. Gives you the basis for a gap analysis for identifying waste. Waste often hides in plain view. That includes material, energy, and labor waste. But the control surface approach, also known as the material and energy balance, forces all wastes to become visible. It's important to pay attention to everything that has to be thrown away. That's where you can find an enormous amount of savings. Okay, that concludes the presentation, and thank you again for listening.